is a mechanism designed for what I like to call online collective effort, thinking about crowds on the web and what they do. So I'll just start out with a general overview of what I mean by online collective effort. So users are all over the web and they're doing lots of good stuff. They're writing reviews. For example, when you go to Amazon and you're trying to decide what to buy, you probably typically read through the reviews that have been written by users, and that really helps your decision. When you're trying to decide where to go out to dinner, for example, you probably look at Yelp reviews. There's online question answer sites like Yahoo Answers, Quora, Stack Overflow. Most of the content comes from users who are not paid to produce this stuff. They're just doing it out of interest. Discussion forums where people just offer each other comments, suggestions, support, and so on. There's of course Wikipedia, which is the best known example of online peer production. There's social media like blogs and YouTube, and most of the content you're reading on the web right now is probably user-generated content by and large. Then there's also crowdsourcing, and here there's both paid and unpaid crowdsourcing and micro tasks and bigger tasks. So for example, there's Amazon Mechanical Turk, which is this huge platform where workers can come in and perform tiny little tasks for tiny little amounts of money. There's citizen science projects where people perform tasks of essentially the same scale, tiny little micro tasks, but without any payment. They just do it voluntarily. There's things like games with a purpose, which are very clever designs that get people to do tiny little tasks without even realizing they're doing tiny little tasks because they think they're playing a game, but actually they are serving Louis Vuitton. And then there's things like contests where you're not really doing microtasks, you are solving larger problems, but it's really online users that are coming in and solving these problems. And finally, of course, now there's online education where the scale of the classes is such that the crowds have created a huge problem. How do you answer students' questions? How do you grade their assignments? And the answer has been to sort of crowdsource the problem back to the crowds themselves. You produce these assignments, fine, you grade them too, you answer each other's questions and so on. So basically there's more and more settings on the web where users are central, user contribution is central. But then if you really look around, quality and participation varies widely across these systems. What I really showed you on the previous slide were the success stories, the systems that by and large seem to work. But then there's also a lot of systems which don't work so well, or systems that seem to work but there are failures. As in, there is still junk content, there is gaming, and so on. And so a natural question that comes up is, how do you incentivize high participation and high quality contributions from users on these sites? If you were to start out to design a new site, or if you were to get to tweak an existing site, how would you do it in such a way that the users actually did what you wanted? So now when you ask this question, there's two components to the question of how do you design incentives. The first is the question of why are people doing this anyway? What constitutes a reward? And there is literature from social psychology that is looking at this question. What is it that drives people to contribute? And how do I tweak motivators so that people come in to contribute? But even once you understand that, there is a second aspect, which is that rewards are limited. And even if they aren't limited, there's the question of how do you allocate them? So once you've figured out what people work for, maybe that's attention, maybe that's reputation, maybe it's status, or maybe it's just plain old money, like in a crowdsourcing contest, how do you decide how to allocate rewards? What do I reward people for? If there's a limited amount of resource, who gets the reward and so on? And that leads to the second half of this incentive design question, which really leads to a game theoretic framework for incentive design. Now, I'm not very sure how familiar everyone here is with game theory, so I'll just give you a very high-level overview of the part of it, at least, that is relevant to what I'm going to talk about. So when you think about a system, such as say Amazon reviews or question-answer forums like Yahoo Answers, the design of the system induces some rules which specifies how rewards are allocated. There is actually a first part which even specifies what those rewards are. So for example, when you look at YouTube, and the fact that it has a like button means that people can give you attention type of feedback. So there is a first aspect of system design which even specifies what kinds of rewards are available. But there's a second aspect which specifies how those rewards are allocated. So for example, Amazon decides to rank reviews according to some function of the votes that are received. And the reviews that get ranked at the top are going to get a lot more comments, attention, and so on from readers than the reviews which go at the bottom. Yahoo Answers, for example, decides to give out some number of points to the best answer and very few points to everybody else. That's a particular reward allocation mechanism. So the system design induces some rules which says here are the rewards and here's how they're allocated. Now, self-interested users are going to make some choices over actions to maximize their payoffs. And when I say make choices over actions, these choices are going to depend on what the system is, as well as what other users are doing, and that's where the notion of an equilibrium will come in. Now, in the kind of settings we're interested in, online collective effort, what are the kind of action choices that users have? This is the first question that comes up. One that you might be very familiar with if you've been thinking about mechanism design, especially in the traditional sense, is one choice you could have is revealing information truthfully. So for example, if you've been studying auctions for a long time, the natural action choice that comes to mind is, do you report your true value for how much you're willing to pay for the item? In the online setting, for example, you may have some ratings of products or so on, and that's the question of whether you reveal it truthfully, and that's not what we are going to talk about at all in this talk. The action choices that we are going to be most interested in, the first is effort. So what does effort translate to in an online setting? So for example, effort could mean the quality of the contribution you make in a user-generated content site. Do I write one of those measly little reviews which says, product worked? Or do I write one of those long detailed ones which says, I bought this so-and-so, it worked so-and-so, it stopped working after 3 months, they helped me, and so on and so forth. So that could be one kind of effort. Another notion of effort is output accuracy. So for example, if I'm performing tasks on Amazon Mechanical Turk, am I really trying? And am I really being accurate on my task? Or am I just doing a lousy job? Effort could mean quantity. So how many questions do I decide to answer? How many tasks do I decide to do on a citizen science project? How many proteins do I decide to label? How many galaxies do I decide to label, or so on? It could also mean speed. So for example, if you think, and this is one of the things we are going to talk about, if you're thinking about, say, an online question answer forum, do I check it frequently and answer quickly, or am I slow and lazy about it? So effort could translate to many things. And finally, another kind of choice which is really important in these kinds of online settings is participation. Because if you think about it, unlike in several settings where you don't really have very much of a choice, in online settings, one choice you really have at the very start is whether to participate or not. And formally, this is called endogenous entry. So if you hear me using that term, what I really mean is that participation is a choice. So for example, I don't have to go onto Amazon and write a review. I don't have to go onto Yahoo Answers and write an answer. I really have a choice, and that is one of the choices over actions that we'll want to be thinking about when we're thinking about self-interested users. Okay, so I said here's a game theoretic framework, here is the kind of things users could do. And I'm asking about the question of how do you incentivize high participation and effort. And at this point, you could ask me, okay, why don't you have one grand general framework? Why don't you tell me what to do when I have to design an online crowdsourcing system? Why don't you have just one common answer? And the answer to that, of course, as is probably obvious to many of you, is that the settings are different. But what specifically do I mean when I say the settings are different in this online collective effort context? A key difference comes because there are diverse motivations for contributions across sites. So there are differing reward types. For example, on some sites, people may be contributing because they like the fact that they receive attention when they contribute. On some other sites, they may be doing it for tiny amounts of money. For example, on Amazon Mechanical Turk, they may be doing it for reputation, they may be doing it for status, they may be doing it for large sums of money like in a crowdsourcing contest. And when you have these differing reward types, you have differences in constraints on rewards. How can you reallocate rewards? You also have differences in available reward regimes. So for example, if you think about attention, a natural thing to say is what happens on very popular sites when attention tends to infinity. On the other hand, if you're thinking about monetary rewards like a crowdsourcing contest, it makes no sense to say that the reward regime is where the reward diverges and goes to infinity, because you're talking real money. It's not going to go to infinity. It is going to stay very bounded and weak. Okay? So that's one reason you have different kinds of problems. And of course, there's also, this is something again we're not going to talk about very much in this talk, there's going to be differences in observability of output. And what I mean by that is this. If you think about a crowdsourcing contest, which gets, let's say, 20 entries and the contest is like some $20,000 contest, the person giving out those $20,000 is probably very willing to sit down and examine those 20 solutions and decide which one is best. On the other hand, if you think about a user-generated content site like Amazon Reviews, I don't think anyone on Amazon is willing to sit down and examine all of the reviews on the site and decide this one is so good and this one is so bad. Okay, so that leads to differences in how carefully you can observe output and therefore what you can reward for. Okay, so that's another reason. So these are the two reasons why there isn't, one umbrella mechanism solution. So that being said, today what I'm going to do is I'm going to talk to you about incentive design for online collective effort in two settings. The first has to do with crowds and education, and here we're going to talk about online peer learning forums. So there are question answer forums of all kinds on the web, but we're going to talk about this very special kind of question answer forums, which is things like Piazza and MOOC forums and so on. And there we're going to ask this question: how do I incentivize the class to participate? How, as an instructor, do I create a situation where I am not answering all the students' questions only online instead of in office hours? How do I actually get the class to contribute, and what can a game theoretic model tell me about this? The second setting I'm going to tell you about is rewarding for overall contribution. So while there has been a bunch of work on rewarding, on how do you allocate rewards for individual things, like how do I give out points for an individual question or attention for a particular question, a lot of contributors on these sites are really not responding just to rewards for a particular question or the attention they got for a particular review. What they're really responding to is their identity as a contributor overall on the site. And there's been a lot of push on the web to sort of reward contributors for overall identity. And one of the things that people have been doing is giving out badges or putting out leaderboards and things like that. And these badges really seem to be valued by users. People do try to get them. But on the other hand, they do require effort. I have to do well to earn a badge, which means that again, badges induce mechanisms. And what we're going to do in the second part is talk about what are the incentives created by commonly used badge designs online, and how do they compare against each other. So this is a high-level overview of the talk. So let me start by talking about online forums for education, and this is joint work with John Kleinberg, who is right there, right next to Bobby Kleinberg. So this, when it says Goshen Kleinberg, it's the first Kleinberg. So, okay, so just like the web has changed everything, it is also changing education. And the scale of the students that can be reached with the web has basically led to very large online classrooms. And so you need to solve the problem of how do you evaluate assignments and how do you answer questions. And the solution has been to turn the problem back to the crowds, and there's peer grading for crowdsourcing assignment evaluations, and there's peer learning forums for crowdsourcing question answering. And what I'm going to focus on is the second part, crowdsourcing question answering. There is research in the educational literature which shows that peer learning is actually a very good thing. It's a good thing for students to learn from each other, and it apparently provides significant educational benefits. And at the same time, online forums for education are really increasing in use. And Piazza, which is not used just for online courses, is something most of us use for offline real-world courses as well. This was when I checked in June, it had more than 2,500 courses and 100,000 students registered on some course or the other. And discussion forums on MOOCs are of course huge because the MOOCs themselves are huge and so on. Now for a forum to be effective, it really requires student participation. Otherwise you're not going to get these peer learning benefits. So the question we're going to be interested in is, what can the instructor do to incentivize the class to contribute? So towards this question of asking how can the instructor incentivize desirable outcomes, and desirable could mean many things. It basically means an active forum, how long it takes to get an answer to a question, how many answers do you get, and all of these things. We're going to start out with a game theoretic model for incentives in education forums, and what's interesting here compared to a lot of the previous work on incentives in these online settings is that rate is going to be a strategic choice. The rate at which a student checks the forum is going to be the strategic choice in the model. And we're going to do an equilibrium analysis, and the equilibrium analysis is going to depend on what kind of question you're talking about, whether it's a question for which a lot of answers are meaningful or whether there's only one answer that makes sense. We're going to be interested in how equilibrium participation scales with class size. Can you get more and more out of the forum as the class grows larger, or do you really not get any benefits with scale? And finally, what can the instructor do to use the forum in an optimal way? Okay? So, a quick note, and I'll make this really quick, about, so these peer learning forums, you can say, look, these are really question answer forums. Why is it any different from Yahoo Answers, Stack Overflow? And people have been looking at those things. I myself have been looking at those things. Why is it different? And the answer is that education forums do differ from general online question answer forums because there is an instructor and because there are social norms. So, because there is an instructor, this instructor can essentially monitor the forum and create incentives, and these incentives could either be explicit or implicit. I could either say, look, I will award you points for in the class for going and answering questions on Piazza. I could do something as explicit as this. Or it could be that there is a social psychological reward. And I certainly, from my own experience, I've noticed that if you go and upvote a student's answer on Piazza, the students just seem to like that, as in, the instructor found this helpful. Yeah, the instructor found this helpful. That's nice. It's not a bad thing when anyone finds you helpful, especially an authority figure. And it could also be social psychological reward from your fellow contributors in the forum. And what all of this does is it creates more disincentive for poor quality and junk content at the same time as well. Because of course the instructor could penalize you heavily for just producing junk. And also there are social norms. As in, if you've been posting really bad stuff on the forum, do you really want to meet your classmates tomorrow and have them know that you are the person that was saying all that nonsense on the forum? Maybe not. So social norms and the instructor together essentially allow us to focus on rate rather than quality. And this is what sort of allows us to say something more in these kinds of forums than we could say in general question answer forums. So quality does remain an issue, but it's not as strongly and evidently a first order issue, so you can afford to focus on other things. Okay, so this is why it's different. Let me just quickly give you an overview of the model, and then we'll talk about all of this in detail. So the model basically says that, so remember we're doing a game theoretic model, so I have to specify costs and benefits. So what are the benefits to the students and what is the cost? So students get a benefit when they're rewarded. What are they rewarded for? They're rewarded for useful, timely contributions on the forum. And this reward could be points towards the grade or a social psychological reward or anything. The model is going to be set up so that the probability of your getting a reward increases with the rate at which you check the forum. And at the same time, the more frequently you check the forum, that incurs a higher cost. Why? Because if you're sitting at the computer checking Piazza, you're not doing something else with your life, and that is incurring some kind of cost. Now, just a heads up that when I say that you're rewarded for a useful, timely contribution, whether an answer is useful or not depends on the type of the question. So, if a question, for example, says, when exactly is homework due? Is it due by 8 p.m. or is it due by 12 p.m.? Look, there's one correct answer to that. And it's not really useful for 12 people to say it. So, we're going to think about, and of course, we are really doing something abstract and looking at two extremes. We're going to look at the two extremes where in single answer questions only the first answer is useful, and in open-ended or discussion style questions we're going to assume that all answers are useful. Okay? And there are caveats here which I will pull up. The strategic choice is going to be the rate of participation, and like we said, the probability of getting a reward increases with the rate, so the benefit increases with rate, but cost also increases with rate, and this is the only thing that's going to set up a trade-off. The students are going to choose the rate in response to the instructor's rate, and this is where the timely part comes in. So if you supply a useful answer before the instructor comes in, you've been timely, otherwise you've not. So depending on what rate the instructor chooses, the students are going to choose some rate to maximize their probability to maximize their overall payoff between getting in time and their cost. So now let me just be more precise about the model. So there's a class with n students, and there's one instructor. And if there's TAs and so on, we're going to think of them as one giant instructor. Okay. There's a single question on the forum, and that arrives at t equal to 0. Of course, the natural complaint is, look, there is no question, there is no forum with one question. But this is actually not a complaint, because we can essentially show that even if you have multiple questions under our model, you can strategically reduce this to the question of just asking what happens with a single question. Okay? The student's strategic choice is going to be the rate of participation, and we are going to model this rate via a truncated Poisson process. The truncation is because no course goes on forever, but don't worry about that, it's a technical detail which doesn't make a difference. So student checks the forum according to a Poisson process of rate lambda j. And we are going to make the assumption that when we say that rate is a strategic choice, you could also ask why isn't the quality of my answer a strategic choice? And here we are going to make the assumption that the instructor monitors quality and he rewards only quote-unquote good enough answers. Okay? So there's some notion of good enough, the instructor is checking this, you get a reward only if you're good. So that's why I'm going to focus only on the rate. We are going to make an assumption. We're going to make the assumption that students can supply an answer to any open question. So if I arrive on the forum and I see that there is an open question, I can supply an answer to it. Of course, this is ridiculous. So you can actually extend our results to the model where students can answer a question with some probability, which may be strictly less than 1. Yes?
Are we assuming the student's ability to answer special questions is identical?
Yes. So specifically, we are assuming that every student can answer any open question on the forum. Yes. So if your question is about this part, about whether when we do the extension, whether we can handle differing abilities, the answer is no, I do not know how to handle differing abilities.
The allocation of the rewards could depend on quality,
So,
ability of students.
yes. So the only strategic choice in the model is rate of participation. Any answer which is good enough gets a reward. There is no competition on quality. There is no strategic quality choice. That's what I've been trying to refer to all this while. When I said that quality is not something you really need to worry about, it's a second order effect. Okay. So the instructor also checks the forum with some Poisson rate, and the rate mu equal to 0 for the instructor is going to mean that he's going to check the forum once at the end and give out rewards, whereas a rate of 0, and of course Poisson variables with rate 0 make no sense. So rate 0 for students is going to represent the fact that they decide to do nothing on this forum. They never show up. So when the instructor comes in, she is going to close the question upon arrival, and she is going to reward useful answers, and there are going to be no further rewards from closed questions. And this could be for multiple reasons. Either it is that I say, if I was giving you course credit, I'm not going to give you course credit if you answer after I arrive. It could be because I'm not going to see answers that are posted on a question after I've already checked that answer once, and what you're looking for is my approval as an instructor. It could be because I disable further answering as an instructor, and now I can't post an answer, and therefore my fellow students can't thank me for it. It could be for any reason, and the model and analysis that we're talking about is completely agnostic as to why students derive benefit from answering. It could be for a whole bunch of different reasons. It doesn't really matter to the model and the analysis. So now let's talk about utilities. The cost of checking the forum increases with the rate at which you check the forum, and for simplicity we're going to assume that these costs are linear, that the cost has a coefficient alpha for the students and a possibly different coefficient for the instructor to model the fact that they might value time differently. We're going to say that a student obtains a net benefit V when he is rewarded for an answer, and this V is basically the difference between the reward and the cost you incurred when you actually answered the question, because presumably you have to think about it and write it down in something that incurred some cost. And the reward V star that the instructor gave you, or the social psychological reward, is V star, and V is the net of those two. So the students obtain a benefit when they receive a reward, and it has some value V. What is the instructor's benefit? We are thinking that the instructor is doing two things. They are watching out for the person who asked the question, and they don't like spending their own time. So the benefit part comes from watching out for the person who asked the question. So the instructor's benefit is going to be essentially the time discounted value from all useful timely answers that have been received, including the instructor's own answer. And the discount factor that we are going to use is essentially going to reflect the asker's impatience. So if this was a question on which the asker wanted an answer very fast, the discount factor is going to be very high. If this was a question which really didn't need an urgent answer, then it's going to be discounted very lightly. Okay? And the specific form we are going to use is the summation of e to the minus delta ti, where e to the minus delta ti is the time discounted value from an answer which was received at ti, summed over all the answers that are received. I want to just point out a couple of things quickly. The times at which these answers are received are random variables, because remember that people are checking the forum at random times. The number of answers that's received is also going to be a random variable. It depends on how many people manage to arrive before the instructor arrives and closes the question. Okay? And notice that the instructor's choice of rate is going to determine both the rate at which people check the forum, so it's going to determine from what distribution these TIs come from, as well as simultaneously how many answers you receive for the same reason. Okay. And for both the students and the instructor, the utility is just going to be the benefit minus the cost. So this is the model, and that's set up. Good. So now let's set up the game. The students choose their rate of checking the forum. How often do I need to go on to Piazza to make myself happiest from this class to maximize their utility? The reward depends on supplying a useful answer in time. The usefulness of the answer depends on the question type. So open-ended questions, any answer which comes in before the instructor is going to get a reward. For a single answer question, only the first answer that comes in is going to get a reward. Remember, we made the assumption that all answers are good, and so on. So lambda j, the rate chosen by a single student, is going to be a best response to the rate chosen by the instructor, because I certainly need to come in before the instructor to get my reward. And possibly the rates chosen by other students. Why? Because in a single answer question, I need to come in first and before the instructor. So I need to beat all my fellow students as well. The questions we're going to be interested in is, how do these equilibrium rates lambda behave? And second, how should the instructor choose her own rate to maximize her utility from using the forum? Because presumably the forum has been set up to make the instructor's life easier, as well as to facilitate peer learning, to get lots of answers in student discussion and so on. So like I promised you, the answer quote unquote depends on what kind of question you're looking at. So let's first look at open-ended or discussion style questions. And here, as we said, the asker benefits from all answers because this is a discussion. All answers are useful, which means that students continue to contribute until the instructor closes the question. So any student who arrives before the instructor receives a reward. What this means is that the students are not competing amongst each other at all. They are just competing with the instructor. So I as a student have a rate which is Poisson lambda. The instructor has a rate which is Poisson mu. Which of us beats the other? That's the trade-off that's going on. So the reward probability, and for those that are familiar with Poissons, which may be pretty much everyone here, is essentially going to be lambda over mu plus lambda when the question is whether a rate lambda exponential occurs before a rate mu exponential. The cost is also alpha lambda, and both of these increase with lambda, right? So my benefit increases, my cost increases. The question is, how does this trade-off play out? So let me first tell you the first result, which is that a student's optimal choice of rate as a function of the instructor's rate is given by a certain function. The form of the function really just tells us the following useful facts. First of all, notice that if the instructor picks too high a rate, then the students just stop responding. This is the case where this instructor is going to answer the question before I do, no matter what. Why on earth am I even trying to compete with this instructor? So I quit. The second thing to, yes, go away. Yes, okay, good. The second thing to note is that this function, which says how quickly the students respond, is a non-monotone function in the instructor's rate. It's increasing up to a certain point, and then it's decreasing beyond that. And what's really going on here is, at first, when the instructor is too slow, it's really not worth coming in quickly and checking the full. I mean, this instructor is not going to show up until day after tomorrow. I can take my time. As the instructor starts speeding up, it becomes more and more worthwhile for me to speed up as well and try to get the reward by being there ahead of the instructor. But beyond the point, the instructor is going so fast that it's not worthwhile for me to try to keep up anymore. Now I just want to sort of keep up somewhat, but my cost is really going up. And then you sort of reach the point at which it's just not worthwhile to participate anymore. Okay? So it's interesting that this non-monotonicity of the student's best response has actually been observed in the educational literature in qualitative grants. And the literature essentially says that, look, you want to go fast, but you don't want to go too fast. You want to motivate the students, but you don't want to make them drop out. Okay? So it's interesting. Yes, a question.
So first, there's no dependence here on the benefit. Have you normalized the benefit to 1?
Yes.
Okay.
Yes.
The second thing is the...
It's going to depend on the cost to benefit ratio. Yes.
Okay.
Yeah. So in some sense, it's all in alpha already. In some sense.
Yeah.
So,
Sure.
So,
Yeah. No.
yeah.
That's
so
fine.
alpha sort of captures that. Yeah.
But the second thing is the instructor's reward had this discount factor in it.
Yes.
But the
I haven't.
the students don't, right?
Yes.
And that's maybe part of this non-monotone thing, because you say, well, if I come in, but if
Right.
the reward was also proportional to that, you'd want to come in earlier.
Yes.
even if they-
So your point is that if I were to have a non-simplistic reward scheme where I give you a reward that depends on how quickly you answered the question, not just whether you answered it before me or after me,
Right.
that might do better. It's not clear to me if the non-monotonicity will go away still. So I haven't analyzed that scheme, but it's definitely a valid scheme. It is more complicated than this binary scheme of do you arrive before me or after me. That's a simple binary thresholding test. Yes.
Can a student answer twice in the same forum or not?
No, we are assuming that you can answer only once. Yes.
So your grade is uncurved, right? In this case, how interested the students are in submitting the right answer does not depend on how many points they have already earned. And how
Yes.
many
Yeah,
other
so,
points
right.
somebody else earned.
So this is really going to be just about your reward for this one question, not about your overall reward from the forum or about how it counts into your grade. So yes, this is really about answering questions into the forum and not about how it goes towards. Yes, that's a very good question.
So there is no mean field game version of this where all people with such and such score, cumulative score and answers on the forum have the following optimal lambda.
There well might be, and that's a very interesting point. It's something I'd like to postpone for later so we can continue. But that is a very interesting thought. Yes, thank you. Okay, so now you could ask the question of the student's rate scales. The student's rate responds to the instructor's rate in a certain non-monotone way. How should the instructor choose her rate? And notice that it's not obvious that the instructor just wants the students to come in fast. And why is that? Because there is a trade-off between speed and quantity. If the students are coming in fast and I'm closing the question at a certain time, there are a whole bunch of answers that are not going to get given because I closed the question early. So there is going to be a trade-off between the number of answers I have and the speed at which I get them. And the instructor's utility function actually weighs both of them because this is an open-ended question and the asker might benefit from both quantity as well as when the answers were received. So it turns out that when you optimize the instructor's utility function, when you optimize the instructor's rate to maximize her utility function, it turns out that the optimal instructor utility in this case does scale linearly with the class size, and this is not going to be the case for single answer questions. And it scales in the following way. The optimal mu star is going to depend on how impatient the asker is, and essentially what happens is this. As the asker becomes more and more patient, the instructor essentially does not try to drive the class fast. What she does is she tries to keep the question open for long enough while still maintaining a positive rate so that she manages to get as many answers as possible, because now the discount factor doesn't really matter, it's quantity that matters. Conversely, when the asker becomes increasingly impatient, unboundedly impatient in fact, what the instructor is going to find it optimal to do is to essentially choose a rate that drives the fastest response from the students. But what happens at this rate is that really there isn't that much response coming in, and essentially the overall benefit goes down all the way to zero. Okay? So there's this trade-off between speed and quantity which is essentially captured by this asker's impatience. And the optimal response of the instructor is going to depend on how impatient the asker is in this question. Now, the situation where the optimal utility scales with the size of the class is going to really change when you start looking at single answer questions where there's just one well-defined answer. Yes, a question.
On the previous slide, how does the instructor know how impatient the student is before he has gone on the phone?
So that's a good question. The instructor doesn't really know. The class doesn't have exactly one question anyway, and these are all things that one would want to construct a distribution over delta and then use that to optimize and decide what you want to choose at the end of the day. Okay, good. So for single answer questions where there's just one well-defined answer, all but the first answer are going to be useless. So what a student needs to do now is not just fight the instructor's rate, but also fight the remaining n-1 students who are choosing some rate. So now you really have a non-trivial game between the students as well as the instructor. So when the instructor chooses a rate, the best response that a particular student chooses is going to depend on the rates chosen by the remaining students as well as the rate chosen by the instructor. And what we are going to look at is the symmetric equilibrium of this given, and we are going to ask how that behaves. One part of it behaves very similarly. If the instructor chooses to go too fast, the students are just going to sit back and say, sorry, I'm not trying to beat you. And that rate is not different at all than in the case of the single answer question, because if it's not worthwhile for the student to beat just me as the instructor, it's certainly not worthwhile for them to beat me plus everybody else. So they're all just going to sit back and say they're going to do nothing. What's interesting is that for any choice of the instructor's rates at which the students are choosing a non-zero rate, the equilibrium student response rate actually scales back with the size of the class. So as you put in more and more students into the class, each of them decides to step back and do less and less. And that at first is very counterintuitive. When you think about it for a few moments or many moments as the case might be, you could argue that it's because the size of the reward has essentially scaled in a different way. When you had an open-ended question, there was basically a reward of 1 for everyone who managed to come in time. Now there is a reward of 1 to be shared amongst everyone who comes in time. You could claim that, oh, in that case, why isn't your problem easy? Why don't you just say that there's 1 over n people, and why don't you just take a factor of 1 over n into your analysis of the open-ended question? That gives you the wrong answer. So you do need to solve for the simultaneous game correctly. Another curious fact is that in this equilibrium, if I am an instructor and I have more than 2 students in my class, which I really wish for every instructor, the best rate that you can choose if you want single answer questions to be answered by the class is to just step out. The value of the instructor rate that maximizes the student response rate is actually mu equal to 0 for any respectable class. Now you could ask, okay, for this kind of questions in the forum, so notice of course, the sad state of affairs here is that the overall utility, and actually this will come up here. No, actually let me just tell it to you now. It so happens that the class as a whole produces an answer the speed of which does not scale with the size of the class at all. Okay? And this is because basically everybody is scaling down their effort. So essentially as the size of the class grows larger and larger, it's not that you get answers earlier and earlier. You still get answers as slowly as ever. You could ask what could the instructor do, what is the instructor's optimal utility, because remember that the instructor has a choice. She can go into the forum and answer the question herself if no one else has answered it, or she could sort of sit back and let the students answer it, or she could do anything in between. It turns out that when you look at the instructor's utility as a function of her choice of rate, when students are best responding to that rate in equilibrium, it turns out that the utility is bimodal and it has 2 local maxima. One in which the instructor's rate is 0 and the class is doing all the work, and the second in which the instructor's rate is non-zero, but it's beyond this value, the value at which students respond. So in the second equilibrium, the instructor is doing all the work and the class is doing nothing. In the first optimal point, in the first local maximum, the students are doing all the work and the instructor is doing nothing. And in between these two, there is actually a local minimum where basically the instructor is working, the students are working, and really no one's very happy. Okay? So that's exactly how not to use the forum. And how these 2 local maxima compare against each other is essentially going to depend on how the instructor values her own cost of effort. If she really values her effort very highly, then it's going to turn out to be that she's going to step back and let the class do the work. Otherwise, it's going to be the one in which she does. So what are the qualitative takeaways from this model? So first of all, in terms of instructor participation, you want to motivate faster student response. You want to choose a rate such that you do motivate the students to contribute. It's not this very relaxed class in which nothing happens. But you don't want to go so crazy fast that you just cause the class to drop out. This was for open-ended questions. when you think about low reward questions, single answer questions in some sense are really low reward questions because the total reward available in that question is fairly small. Too much competition is just hurting outcomes. Having a very large class is just not turning out to be as productive as you thought. And here there are local utility minima where the instructor could go at a pace which is neither good for herself nor good for the class. Neither the class responds as best as it could, nor does the instructor step back and do other things as best as she could. What does this kind of analysis tell us about design, what an instructor could do? So there's a theorem that you can show. So let's say I'm running a real class, and let's say the class is such that the students are largely asking single answer questions. So students have gradually latched on to the fact that this is essentially a low reward forum. If I as an instructor were to inject questions into the class, open-ended questions, every so often, for any positive probability of finding an open-ended question on the forum, what you can basically show is that the instructor can choose a rate in such a way that suddenly you get the class active and moving, and that the best response that you can obtain essentially scales with the size of the class. Okay? So I didn't go into the details of this result, but essentially what you can do is you can show that you can mix questions in such a way that the gains that you could get with open-ended questions can, with a very small fraction of open-ended questions, also translate to a forum that's largely full of single answer questions. So I'm now going to move on to the second half of the talk, and given that I have about 15 minutes, I believe, the way I'm going to do this is I'm going to talk very quickly and I'm not going to say very much. So what I'm going to talk about here is joint work with David Easley. I'm very lucky to have both of my co-authors here today. So this is about rewarding users for their overall identity on the site. And gamification is now a huge rage on the web. Let's get users to compete. Let's give them reputation. Let's give them leaderboards. Let's give them badges. And this seems to be something that many companies, many websites have really taken to. And these are really virtual rewards based on site-level cumulative contribution, not just for one question or one answer, but overall rewarding you for your identity on the site. And gamification really somehow appears to work. There's both formal analysis of this showing that badges motivate users. This is a paper that John has with a bunch of other people. And there's also a ton of anecdotal evidence. If you go on the web and search for Amazon top reviewer lists, you find this whole bunch of discussion forums where users are talking about how to get on that list and how many reviews do you need to write and so on and so forth. And the question we're going to be interested in is what incentives does gamification create for strategic users? And very specifically, we're going to look at a certain kind of question. So I'm going to use the term badge to refer to any kind of top contributor reward. It doesn't have to be really, one of those silly little circular things with little bows around them. Anything like a top contributor reward, for example, also is something I'm just going to use the word badge to indicate. So there are different kinds of badge designs online if you think about it. There are activity milestones. So for example, Stack Overflow gives you a badge if you do a certain amount of work and so on. There are top contributor badges, Yahoo Answers and Quora and TripAdvisor. If you're amongst the top something contributors on the site, you get a badge. There's top reviewer lists on Amazon, which is an even more nuanced version of top contributors. And these badges, if you think about them, they're clearly valued by users. That's what all of this anecdotal evidence and formal evidence seems to suggest. But clearly they require effort. I have to go and put in work on the site to earn a badge. And what that means is that badges basically induce mechanisms. And now you could ask the question, okay, if badges induce mechanisms, the design of a badge, what you award a badge for, how many of a badge do you award, and so on, is something that's going to affect the participation and the effort that you get from users on the site. So what are the incentives that are created by different badge designs? So what we did in this paper with David in EC 2013 was we did an equilibrium analysis of the incentives created by badges. How do you formally model these? For example, what we focus on is absolute and competitive badges. So Stack Overflow awards you badges for meeting a certain level of effort, whereas a whole bunch of top contributor type of badges say you have to be amongst the top so many contributors. That's a competitive or a relative reward. What are the mechanisms induced by these absolute and competitive rewards? When you talk about competitive rewards, really, there's actually a nuanced question in there. given that participation is a choice, if I have a population of 7,000 sitting around that potentially could contribute to the site, should I award a badge to the top 10% of these 7,000 possible contributors? Or let's say only 700 people posted answers in a certain week. Should I be awarding it to 10% of the 700 that actually posted? So when participation is a choice, the number of people who could potentially contribute and the number of people who actually contribute are not necessarily the same number. And so you have this question, should I be awarding to the top 10% or to the top 100? So an absolute number of relative rewards or a relative number of relative rewards. And finally, if you think about it, these badges, they're really social psychological rewards. It's not like handing out $5 or $10 and the value of $5 to me is the same whether, say, David got $10 or whether he got nothing. If too many people have badges, maybe I don't like the badges anymore. Maybe they're worth nothing. And maybe if there's only a very small number of people who have badges, maybe the badges become more valuable. So what if the value from winning a badge actually depends on the number of other people who also win a badge? What happens to equilibria, what happens to incentives and so on? And also from a design perspective, should I let people know how many other people are winning a badge or should I leave them to figure it out for themselves? So if you think about it, when you go on a site like Stack Overflow, next to its badges it says very clearly, so many people have won so and so badge. When you go to a site like Yahoo Answers, you really have to fish around to see who's a top contributor and who's not. There isn't one place where you can go and look at the number of people who have each top contributor badge. I mean, if you go browse around the site long enough, maybe you get some idea. Okay. So, from a game theoretic perspective, as considering information as a design choice, should you be supplying precise information or should you not? These are the kinds of questions we're going to be interested in. And we're not going to say very much about the answers, unfortunately. So I will give you an overview of the model and then I'll give you an overview of the results. And then I'll talk about a whole bunch of open directions. So the overview of the model that we used to analyze and answer these questions looked like this. We used a continuum of users and this was really important to us technically because if you think about relative rewards, life is a mess if you don't have a continuum. But because you had a continuum, life was actually feasible to analyze this mechanism. Agents make strategic choices about whether or not to contribute, whether they're going to get on this website at all or not and try to win a badge, and how much total effort they're going to put in. And this effort you can think about as either the quality of the contributions they make or the number of contributions they make or the time they put in. It can mean one of many different things. As in the previous model, again that's going to be the same nature of the trade-off. The more effort I put in, the more output and the higher my probability of winning a badge, the higher the cost to me. Okay? So more effort leads to higher benefits and higher costs. Outputs are going to be observed noisily by the system, and this is basically meant to reflect the fact that on most of these sites, like if you think about let's say Yahoo Answers or Stack Overflow, the quality of my contributions is not something that's judged perfectly. I get user votes or something, but those are noisy evaluations of the quality of my output. They're not perfect evaluations. And the mechanism assigns badges based on observed output, and agents who win badges derive value and losers get nothing. And we're going to compare badge design, and I'm going to skip over the details of the model. So yes, so just to clarify what I mean by absolute and relative standards mechanisms. So an absolute standards mechanism is going to be one that rewards any contributor who meets some specified threshold level. So for example, Stack Overflow awards you a legendary badge if you earn 200 reputation points at least 150 times, a mouthful of a definition. This induces an absolute standards mechanisms, which says that if when you choose effort strategically in response to a specified standard, there's some probability that you meet that standard because your output is observed noisily. What effort and participation levels are picked in response to this. And when I talk about relative standards mechanisms, what I'm talking about is top contributor badges, where I reward users who exceed some output level relative to other users. So here, for example, you could think about Amazon, which has this top reviews list, Quora or Yahoo Answers or so on. And this induces a relative standards mechanisms where so agents choose efforts, they produce some outputs, look at the top row of these agents in this continuum of abilities, badges go to all of them. And here, of course, there's the subtle question where what does row even mean? So there are really two versions of the mechanism. One where you reward the top row fraction of actual contributors, the people who chose to participate and contribute, and the second where you reward the top fraction of potential contributors. And I really want to emphasize this point that when participation is a choice, these two numbers need not be the same, and therefore these two mechanisms need not be the same, and as it turns out, they actually are not the same at all. They are in fact quite different. So let me, in the last 5 minutes, let me tell you about one second, let me just, yes. So let me tell you about how the equilibrium analysis is to be interpreted, since there isn't time to go into the details of it. So it turns out that when you set up these mechanisms and analyze the incentives, first to answer the question of should you reward the fraction of actual contributors or the fraction of potential contributors in a relative standards mechanism, the answer turns out to be that you really want to reward a fixed number of winners, which is the fraction of potential contributors. You don't want to make the number of rewards contingent on how many people actually participate. That turns out to be a bad idea. When you want to ask the question of if I am setting up a site, should I be choosing an absolute badge or should I be rewarding for relative activity, the answer turns out to be somewhat nuanced. So if you knew your population exactly, you can compute the optimal absolute standard to request from this population. You can also compute the optimal fraction of contributors to reward. It turns out that these mechanisms are actually equivalent for a certain range of parameters, and this range of parameters actually happens to contain the points that optimize the absolute standards mechanism and the relative standards mechanism respectively. But if you really don't know your population, then it matters that you might fall into the region where these two mechanisms are not equivalent. And when these two mechanisms are not equivalent, it turns out that the mechanism which rewards relative contribution rather than absolute contribution is certain to always elicit participation, whereas in the absolute standards mechanism you may be asking for too much and no one may do anything at all. Okay? So if you don't know your population, roughly speaking, the mechanism which rewards for relative participation is more robust. Okay? And that's the mechanism you might want to use. And finally, to answer the question about endogenous valuations and information, I will actually just tell you the answer. So if you have a choice about whether to display information or not about the number of badge winners, and the question is, should you be displaying precise information about how many people have won a badge when people's value from winning a badge depends on how many other people have that badge? The answer turns out to depend on the convexity of how people value winning a badge as a function of how many other people have it. So if my value for winning a badge drops in a convex way with the number of other people who are winning the badge, then what I really should be doing is I really should not be releasing information about how many people are winning the badge. On the other hand, if that value is concave, then I just want to go out there and say this is how many people have won the badge. So this actually gives me a very precise empirical question to go and ask. Do you want to decide how much information to release about the population? Go and try to find out from them whether they value a badge as a function of the number of other people, and take a look at that function. If it's convex, you have an answer. If it's concave, you have an answer. If it's not, please don't come back to me because I'll be hiding in an office somewhere else and I don't want to talk to you. Okay, so just to summarize in the last 3 minutes, not bad at all, what we talked about here was incentives in online collective effort in a game theoretic framework, and we talked about two settings. We talked about crowdsourced question answering in education, in peer learning forums, and we talked about virtual badges to reward contributors for overall identity. And there are other settings where you can do the same kind of analysis and design, which is about contribution quality in user-generated content, peer grading, and so on, crowdsourced evaluation. And what this kind of game theoretic framework does is the following. As we saw, it's not just an entertaining set of math problems to work out, though it is that as well, and I really enjoyed that. It does yield qualitative design recommendations, and it also gives you sharp empirical questions to make those recommendations. So for example, if you have a vast wealth of data, there's lots of data, sure, but what questions do you ask about it? this kind of analysis can tell you what questions might be the most useful in terms of how you might best design your site. That's one useful thing that you could get out of this. And there's a ton of open directions in this general area. So first of all, of course, there's the theory aspect, which is models and mechanism design and analysis for a bunch of very curious questions, especially about how do you evaluate contributions from the crowd by the crowd. When you have a ton of contributions, you can't get a neutral expert to judge them. You have to get the crowd to judge them. But the crowd also has its own incentives because it's trying to compete as well and win. So you have this very interesting kind of evaluation problems. How do you elicit effort when there is this kind of strategic contribution trading? Not just the voting problem, but how do you also elicit effort in this kind of setting? What I started talking about in the context of badges was just a very simple model of overall contributor rewards. How do you think about more complex models for and mechanisms for rewarding overall contribution? And one thing that I think is really important is how do you reward for sustained contribution? And here there's really two aspects. What gets people to stay on in a sustained fashion, and how do you design mechanisms knowing that? So both what's the reward, both the social psychology and the mechanism design part I think are relatively open there. And there's things about different participant roles and so on. There's also a whole bunch of very interesting experimental and empirical questions. So for example, when I talked about badges and relative and absolute badges, I didn't show you the model, but in the model I happened to say that the value of winning a badge is V. Now, says who the value of winning the badge is the same V for a relative badge and an absolute badge. Maybe people who like competitive badges value them differently than people who value absolute badges. And this leads to this question of a reward-dependent endogenous population selection. If I as a site am offering absolute rewards, presumably I attract a population that likes meeting goals rather than competing with each other, perhaps. And when I offer only competitive rewards, perhaps I attract a different kind of population. What kind of work are these people willing to do, and how do they value the rewards? Okay? And this is not a question that any amount of theory alone can answer. You really need to find out how people behave, either empirically or experimentally. Second is the question of mixed incentives. If I were to award both absolute and relative rewards, how do those two interact with each other? And very much more generally, on several sites that actually offer monetary rewards as well as leaderboards, there's financial rewards as well as status rewards. How do these two rewards interact with each other? Do people add them? Do people trade them off against each other? Does one crowd out the other? What really happened? And finally, I think there's some very fundamental questions regarding the economics of social psychological rewards. Money as a reward is something that's really relatively well understood in the economics literature. People have concave utilities for wealth. Money discounts with time in a certain way. It grows in a bank at a certain exponential rate. But how do social psychological rewards really behave? So, for example, what's the shape of reward function? So, if people like attention, what's the marginal benefit from increasing attention? Is it concave? Is it convex? Do you like attention and need it more the more you've got? Do you like it less? And so on. And how do rewards retain value over time? We sort of have some understanding of how money accumulates value over time, but how do social psychological rewards behave over time? So there is a whole bunch of interesting theory questions, and really together with that also a bunch of very interesting empirical and experimental questions about how people really behave. And I'll leave it at that. And it's let's call it 4:30 because we started a little late. Thank you. Eva.
I guess I'll ask a question.
Sure.
So, in the theory part, you were all doing equilibrium analysis. You looked at, set up a model, and then you worked out what the equilibrium is. And I gather what's behind much of what you were talking about is that the equilibrium in these models is unique, I think. Or is it? Or at least the symmetric equilibrium
Yes.
is unique or something.
Yes. Yes.
So one interesting thing in watching these forums is the dynamic. Like some
Yes.
forums sort of start out with,
Yeah.
no one answering and then it builds, and other forums start out by lots of people answering and then it
Yeah.
drops off.
Yeah.
And so
Yeah.
I guess one question is, what can one say even about the exact models you're using or similar models if I care about the dynamic?
That's a very interesting question, and it's a question that I've been also curious about but never really done anything about, because everything we are doing is really in this one-shot simultaneous game sort of model. And you could ask the question about if you were to consider periods, actions in certain periods, and then the action in the second period depends on what happened in the first period. And that's a really good question, and I think it's a really interesting sort of question to think about. It's a really nice issue. Yeah. Yes.
So let me ask a potentially related question. So suppose that your game is basically static, but you don't know all of these things that you think you might not know about
The
what
population
people's evaluation
parameters.
function are.
Yeah.
But you've got some parametric family. You think you kind of know what types of things are.
Okay.
Is there any sense in which you can adaptively choose your reward mechanisms in a way that's going to improve over time?
So I haven't worked on that question, but it is an interesting question, and let me just make sure I understand you correctly. So what you're basically saying is you want to learn the parameters of the population and use those parameters to tune your mechanisms as you go along. Yes, that is a nice idea. The one thing that I think is delicate about this kind of idea is participation. So if you're sure to have your population and have them intact throughout the duration of your learning, then you're good. If your population is going to react badly to some of your experimentation and drop out, then you don't have the same population to experiment on in the next period. So this is an interesting question, and I think the participation choice is going to make this far more interesting than a simple learning problem. Yeah. So I think that's a very interesting question also. Yes. Yes, Paul?
Is this methodology being used on Piazza for Info 2040 now?
2040. I know the people who are responsible for that. That's Eva and David. Please.
What do you mean by whether yes, we are using Piazza and people hopefully are answering some questions, and maybe that's why I asked about the dynamic, because some moments it's going better than other moments.
Are the instructors throttling their activities in order to...
Yes. Yes, not necessarily using the theory, but yes.
I ask the question very slowly.
But actually, if I think about 2040 as over the 3 years I have been involved, and that's exactly the 3 years we've been using Piazza, we invented different rules for the TAs to induce class participation, like how fast, I make recommendation to the TAs how fast they should respond to questions, which is the idea is to induce student participation. I don't know if I'm using the theory, despite that I might also think about the theory, but I'm certainly playing with the parameters here and trying to make it work.
One thing we have casually observed in the theory of class, I should have thought of it before, is that if the TAs answer questions very quickly, the CPPs the students do not, which makes good sense. And we haven't tried to tune it the way this suggests. We should.
We are trying. We're trying. I don't know. I think we're trying.
Yeah, I guess you also suffer a trade-off, right? If you try too hard and you don't answer fast enough, then the kids are all going to be at office hours, and then the questions need to get answered.
I'm not so sure. They get mad at me. That is probably
okay,
true.
There's a negative outcome from too much experimentation. There's a cost to experimentation. Yes. Other questions? No?
Let's end again.